I am J. Abhisar from CSC A section. Today I explain introduction to selection sort, examples of selection sort, pseudocoding selection sort, advantages and disadvantages in selection sort. Introduction to selection sort. Selection sort is simple sorting algorithm. It selects minimum element each iteration, places element in correction sorted position. Easy to understand and implement. It used to small datasets only. Basic concept for beginner learning. Definition. Selection sort is defined as repeatedly finding a smallest element. Swap it with current position. Divides array into two parts. Sorted and unsorted sections maintained. Process continued until sorted completely. Comparison based sorting technique. Working principle of selection sort. Find minimum element in unsorted array. Swap with first sorted position. Move boundary of sorted part. Repeat for remaining elements. Continue until array sorted. It explains simple step-by-step process. Sorted example 1. Array. For example, let us assume 64, 25, 12, 22, 11. First pass minimum is 11. Swap with first element. Second pass minimum is 12. Swap with second element. Continue until sorted. Example 2. Array. Let us assume 5, 3, 8, 4, 2. First pass minimum is 2. Swap with first element. Second pass minimum is 3. Swap with second element. Continue sorting process. Algorithm steps. Start from first index. Assume minimum index current. Compare with remaining elements. Update minimum when needed. Swap elements after iteration. Repeat until complete sorting. Flow explanation. Outer loop controls process. Inner loop finds minimum element. Swapping places current value. Sorted part increases gradually. Unsorted part decreases stepwise. Process repeats until sorted. Headings. The introduction, definition, working principle. Algorithm steps. Advantages of selection sort. Simple and easy to understand. No extra memory required. In-place sorting algorithm. Favor swaps compared to others. Good for small datasets. It is useful for teaching purposes. Also, advantages continued. Works well in memory limited systems. Easy implementation in all languages. Clear logic for beginners. Predictable performances always continued. No additional data structures required. Good for academic learning. Disadvantages. Inefficient for large data sets. Time complexity is O(n) square. Does not adapt to sorted data. Not stable sorting algorithm. More comparisons required always. Slow compared to advanced algorithms. Not suitable for real applications. Performance decreases with size. Unnecessary comparisons done. Less efficient than insertion sort. Not used in practical systems. Limited real world uses. Time complexity of sorted selection sort. Best case is O(n) square. Average case is also O(n) square. Worst case is O(n) square. Small for all input conditions. Comparisons always constant. Inefficient for large inputs. Space complexity. Space complexity is O(1). No extra memory required. Uses only temporary variable. Efficient in memory uses. In-place sorting technique. Suitable for limited memory. This is this code. Hash include stdio for I 0 to n minus 1. Find minimum index Z loop. Swap elements using temporary pointer. Print sorted array. End program. This is the example of sorted technique. Selection sort. In this figure, 13 is smallest. Swap 29 to 13. Second, 29 is smallest. Swap 72 to 29. Third step is 36 is smallest. Swap 98 to 36. Fourth step, 51 is smallest. Swap 72 to 51. Fifth step, 52 is smallest. Swap 87 to 52. Sixth step, no swap. 66 is smallest. So, no swapping. Eighth step, 72 is smallest. Swap 87 to 72. Conclusion. Selection sort is simple algorithm. Easy for beginners learning. Not efficient for large data. Used mainly for education. It helps understand sorting basics. Foundation for advanced algorithms. Thank you.